Here today we would like to talk about the new way of doing spectrum analysis at higher frequencies. We are talking about the MS2760A, the first real small and lightweight millimeter wave spectrum analyzer, going up to, at the moment, 110 gigahertz and usable even up to 125 gigahertz. And we are demonstrating here today the capability by measuring a car radar on typically 78, 79 gigahertz. And usually the task for the engineers here to measure what is the output power of the sensor, what is the occupied bandwidth, what is the time domain behavior and things like this. And this 2760A is giving you here the information about the sweep trace. You see here the center frequency of around 77 gigahertz. You see here approximately the 1 gigahertz range, and for sure we can measure this also. If we are going here to occupied bandwidth measurement, or if we are going here to channel power measurement setup, and that is here 970 megahertz. Okay, a little bit off the frequency here for the moment, but you see in principle, measuring the occupied bandwidth, measuring the channel power, this is here the task that this unit would like to do. And specifically important is that we are bringing the point of test as close as possible to the device on the test, because using cables on millimeter wave frequencies are first of all expensive, and the attenuation and the performance of the cable is destroying the dynamic range. And this is an important thing. At higher frequencies you have to have dynamic range, for example also 100 decibels, and beside this you have to have in place all this resolution bandwidth, this video bandwidth is available, like a benchtop spectrum analyzer. And to close the applications for this, not limited to the car radar applications, this is also the ideal tool for any kind of a drone application, where you are putting this underneath the drone and, for example, measuring path loss behavior of 5G in narrow street canyons in dense urban cities.